Here's a review on forces, and this will be our first part of the review. First, we must know that when forces are in equilibrium, that means that the net force is equal to 0. Therefore, our net acceleration is equal to 0 because force equals mass times acceleration. And we have static equilibrium where acceleration is equal to 0 because an object is not moving at all. Or we have dynamic where acceleration is equal to 0 because the speed is constant, or the velocity. A lot of times we talk about equilibrium in terms of the sum of forces in a particular direction. So the sum of the forces in the x direction or the sum of the forces in the y direction being equal to 0. And remember, this sigma means sum. So if we're talking about the sum of the forces in the x direction, we'd have to say fx1 plus fx2 plus fx3 and so on. One of our forces that we always have in the y direction if an object has mass is the force due to gravity, and that is equal to mass times acceleration, and that is in particular the acceleration due to gravity, and therefore that's equal to mass times gravity, where gravity is negative 9.8 meters per second squared, or negative 32.2 feet per second squared. And that is also equal to weight. When we talk about normal forces, when we talk about normal forces, that is the force that is perpendicular to the surface that the object is sitting on. So if an object is sitting on a flat surface where it has a downward force due to gravity, its upward force, the ground pushing back up on the box, would be the object's normal force. Whereas if the object were on an inclined plane, that force due to gravity would be directed straight down, but the normal force would be at an angle, and that angle is the same angle at which the plane is inclined. So this angle here from the dotted line, theta, is the same. So this theta is the same as this theta in any problem. Now let's talk about terminal velocity. Actually, before we talk about terminal velocity, let's talk about friction. And we have 3 different kinds of friction, but in this video I'm going to just talk about 2 of them. One of them is static, and one of them is kinetic. Static is not moving. Kinetic is moving. Our coefficient of static friction is written mu s. Our coefficient of kinetic friction is written mu k. Both of the forces for both static and kinetic friction are written mu times the normal force. But the mu for static friction and the mu for kinetic friction are different. And remember, the normal force always acts perpendicular to the surface on which the object is sitting. The higher the coefficient of friction, the stickier the object or surface is. So high mu equals sticky. And yes, that is a technical term. And notice that in these equations, neither depends on, or actually just in particular the kinetic, because the kinetic is the only one that's moving, it does not depend on speed that the object is moving, because neither of these terms includes the object's acceleration or speed. It only talks about the normal force and the coefficient of kinetic friction. To calculate the coefficient of static friction, we can say that our mu is equal to the tangent of theta. And that theta is the angle of repose. And that's the angle at which an object will start moving as you lift an inclined plane. So, if my inclined plane starts like this with an object on top, and I keep lifting it and lifting it, the angle at which this object suddenly moves would be the angle of repose. Example 5.14 would be a good example to look at in your book for solving problems involving friction and weight and normal forces and angles.